Trade winds, often referred to as easterlies, are persistent winds that blow from east to west in the Earth's equatorial region. They play a crucial role in shaping global weather patterns and have historically been instrumental in maritime navigation and trade routes. These winds typically originate from the northeast in the northern hemisphere and from the southeast in the southern hemisphere. They are strongest during the winter months and when the Arctic Oscillation is in its warm phase. The term trade winds has its roots in the early 14th century, where trade meant path or track, emphasizing their importance in navigation. For centuries, trade winds have served as the highways of the sea, facilitating the movement of sailing ships across vast oceans. They enabled European exploration and colonization of the Americas and established trade routes that connected distant continents across the Atlantic and Pacific Oceans. In meteorology, trade winds act as the steering flow for tropical storms that form over the Atlantic, Pacific, and southern Indian Oceans. These storms, known as hurricanes, typhoons, or cyclones depending on their location, rely on the trade winds to guide their movement across the ocean and sometimes make landfall in regions like North America, Southeast Asia, Madagascar, and East Africa. Within trade wind regimes, shallow cumulus clouds are common, capped from growing taller by a trade wind inversion caused by descending air from the subtropical ridge. The strength of the trade winds inversely affects rainfall patterns in neighboring landmasses. Weaker trade winds often result in increased rainfall, while stronger trade winds lead to drier conditions. Clouds which form above regions within trade wind regimes are typically composed of cumulus, which extend no more than 4 kilometers, 13,000 feet, in height and are capped from being taller by the trade wind inversion. Trade winds originate more from the direction of the poles, northeast in the northern hemisphere, southeast in the southern hemisphere, during the cold season, and are stronger in the winter than the summer. As an example, the windy season in the Guianas, which lie at low latitudes in South America, occurs between January and April. When the phase of the Arctic Oscillation, AO, is warm, trade winds are stronger within the tropics. The cold phase of the AO leads to weaker trade winds. Moreover, trade winds transport Saharan dust across vast distances, enriching soils in regions like Latin America, the Caribbean Sea, and parts of North America. This dust can influence weather patterns, suppress rainfall, and even affect air quality by adding to airborne particulate matter. The understanding of trade winds dates back to the early maritime explorations of the Portuguese in the 15th century. They recognized the importance of these winds in navigation across the Atlantic and Pacific Oceans, shaping their trade routes accordingly. Trade winds are part of the Hadley cell circulation, where warm, moist air rises near the equator, creating a low-pressure area known as the Intertropical Convergence Zone, ITCZ. When located within a monsoon region, this zone of low pressure and wind convergence is also known as the monsoon trough. Around 30 degrees in both hemispheres, air begins to descend toward the surface in subtropical high-pressure belts known as subtropical ridges. The subsident, sinking air, is relatively dry, because as it descends, the temperature increases, but the moisture content remains constant, which lowers the relative humidity of the air mass. This warm, dry air is known as a superior air mass and normally resides above a maritime tropical, warm and moist air mass. An increase of temperature with height is known as a temperature inversion. When it occurs within a trade wind regime, it is known as a trade wind inversion. When dust from the Sahara moving around the southern periphery of the ridge travels over land, rainfall is suppressed and the sky changes from a blue to a white appearance, which leads to an increase in red sunsets. Its presence negatively impacts air quality by adding to the count of airborne particulates. Although the southeast US has some of the cleanest air in North America, much of the African dust that reaches the United States affects Florida. Since 1970, dust outbreaks have worsened due to periods of drought in Africa. There is a large variability in the dust transport to the Caribbean and Florida from year to year. Every year, millions of tons of nutrient-rich Saharan dust cross the Atlantic Ocean, bringing vital phosphorus and other fertilizers to depleted Amazon soils.